Hey everybody, thanks for joining us today. My name is Jeff Jordan. I'm the engineering manager here in San Diego for GoEngineer. We had a solid list of people sign up for this, so I'm going to give people another minute or so to join us before I start rolling. This is part 1 of 2 for automotive harnessing. So using SOLIDWORKS Electrical. So I tried to deliver this as a single 30-minute presentation towards the end of last year, and it was a disaster. I got through, about half of it and was kind of did a little tease for the other half and said, hey, check us out, soon. I'm going to put the other half up. And so I'm guessing that we have some of the same people joining us that may have seen that before. Format, I kind of have this set up for a 30-minute session. First few minutes, I'm going to go over some basics for SOLIDWORKS Electrical just to so we all have the same terminology for the software and kind of what we're trying to do with it. And just like anything else, go ahead and ask a question in the web meeting here, or I'm going to have my email at the end. Definitely follow up, either reply to the message that you got for the for our invite here, which our marketing team will get and send over to me, or send me an email directly. We're definitely interested in chatting about your applications. So figure we might as well roll in here. So electronics versus electrical. This is the first question that we get with this software, and we found that it's kind of an in-house distinction. So we try to come up with some common vernacular here. For some people, electronics, they might say electronics and electrical meaning the same thing. Electronics, people are referring to boards, surface mount devices, components, usually they'll say through-hole components, surface mount components. They're generally talking about PCBs, so printed circuit boards, traces, layers, these are all electronics terms, whereas when we say electrical, what we're referring to would be wire and cable schematics, wire harnesses, and then everything that goes up from there. So panels, cabinets, ducts, guides, terminals. For the purposes of this, harnessing, most people understand when we talk about harnessing that we're not talking about boards. But when we talk about, hey, SOLIDWORKS has a fantastic electrical tool, it's our fastest growing product, people say, great, I'd love to talk about my PCB needs. And it's like, well, it's actually a different product. It kind of hurts my feelings because I don't support our PCB product like I do this one. So when I say electrical, I'm basically talking about wires and components. And this tool especially, it goes up from the board all the way to project management basically. So we'll cover that. So little background, everyone hears SOLIDWORKS, they think stuff. This is devices, this is manufacturing aids, this is things that you build with metal, things that I would injection mold with plastic. They don't generally think of these types of components, our electromechanical stuff. This is everything that interfaces with the mechanical components that you all already have in SOLIDWORKS, but they tend to be electrical components. So with this tool, we're trying to have one place to represent both. So of course, you probably, if you've heard of this software, you've probably seen a panel demo somewhere. So we can do panel components, DIN rail mount components, and all that. Our electromechanical components that live elsewhere, we can represent those as well. So some of the things, just so we have some visuals here, this would be a panel. For automotive harnessing, which extends into aerospace, defense, harnessing elsewhere, industrial equipment, we're generally not talking about panels. There might be a panel somewhere, but if somebody's coming to me saying, hey, I have harnessing needs, my harnessing needs aren't being met, I'm not going to show them a panel. And up until maybe 18 months ago, 2014 or so, this is pretty much everything that we showed for SOLIDWORKS Electrical. Now, we also can do harnesses. So this is the big show here is these two things, panels and components, are almost completely separate. They're almost mutually exclusive with their needs. Here we're not doing anything that mounts on a DIN rail. We're not doing anything that wires directly in, usually. There's a couple pigtails on this harness here, but we're generally talking about connector to connector and how we manage that information and how we manufacture that. So that last part, how do we manufacture it? How does software help you manufacture anything? Just like going to 3D helped everyone with design communication, design intent, and manufacturing with the original SOLIDWORKS, SOLIDWORKS Electrical is making it much easier for us to take our design intelligence, put it into the computer, reuse as much data as we can, and grab as much out of that as we can, and then put together a manufacturing document. So this is a very simple harness using some 6-pin circular connectors, but this is a 2-scale drawing on a D-size sheet of this harness with complete pin information. So you can see, I don't know how well this is coming across the webinar, but we have colors for each of these pin locations. We have a full circuit summary that has every wire. We have individual wire lengths down to the, it's laughable, 10,000th of an inch. And so this is kind of what we're talking about. This is the goal. And if that's interesting, keep watching. This is kind of what that process looks like. This would be a very complicated harness laid out on a pegboard. You can see in the background of this very happy gentleman's shop, he's got lots of these pegboards. So this is a wire harness manufacturing business, and they have to create these pegboards from scratch. So usually they're setting these up based off of a drawing. SOLIDWORKS Electrical can actually give you this pegboard drawing. So there's a big advantage there. What does your drawing look like now? I'm blowing through these as quickly as I can here. Generally, when we talk about wire harness manufacturing, my previous business in my life before GoEngineer, I owned a business that did specifically this: automotive wire harness design, manufacturing, powertrain engineering. And we would generally do drawings that were just good enough to get whatever it was that we were trying to make made. I need to give my guys in the back something that they can go off of. So maybe it's this power distribution thing here on the left. Maybe it's I'm diagramming some sort of mechanical switch over here on the right. And I'm saying, no, this is how it works. Now go make it. Well, neither of these are very good, right? So SOLIDWORKS Electrical has basically is built off of the assumption that everyone follows a similar design process. And here it is. You basically have a drawing stage. So this is where you do the logical definition. So we've got a switch over here. In this little example, we've got a switch and an e-stop and a relay. And then you do the part selection. You say, for this switch, we're going to use this part number. For that e-stop, we're going to use that part number. And then you do what they call the cable drawing, but basically it's the interconnect between all these components. Next, you generally would leave your schematic tool or leave your pencil and paper and go to something like Excel. So you're going to create your BOM. You're going to go to all these websites. You're going to find out what stuff costs, what the pricing availability is right now. Then you're going to create your net list, your wire cable list, your from to list. These are things that are going to help you actually make this thing. And you generally need a list of what all these wires are so you can decide what type of wire to use for this stuff. And these are all separate processes, right? These are all, individually one step, then another step somewhere else, another step somewhere else. I laugh when I see the audit stage. The audit stage is what you do when it doesn't work, right? You audit your drawings, you audit the BOM, you verify connections. And if you need to make any changes, hopefully you find out before you have a smoking pile of plastic somewhere. But then if you need to make any changes, you go all the way back to the drawing phase. So here's the 10-second pitch, right? SOLIDWORKS Electrical is going to make you more efficient with this first section here, and it completely automates these second two sections. So the pull is, you're replacing whatever schematic tool, whether that's pencil and paper or AutoCAD or Visio or whatever it is, with SOLIDWORKS Electrical. You're going to do these same first steps: logical definition, part selection, cable drawings, and you're going to get these other two steps for free, and they're going to be error checked by the software. So that's, if you were going to stop watching right now, you've got most of the value here. How does it do it? And I'm consolidating a bunch of this so that we can get through as much as we can here in our 30 minutes. We have these multiple document types. Upper left here, we have a single line. Lower left here, we have a multi-line. Upper right, we have reports. And then lower right, we have 3D. Well, all of these feed and get fed from our SQL database, our SOLIDWORKS Electrical database. So that's how we're able to do all of this and have all of these checks and build all this intelligence into the software, because it's all built on database backend. And the heart of this collaboration, as we like to say, is the manufacturer parts library. So this is a shared library across 2D and 3D users. It's built inside a SQL database, so it's incredibly fast, and it's all designed to be easily searchable and very robust. So this has all of our metadata, right? So this is a relay, maybe not the most interesting example for an automotive harnessing demo, but we've got a relay. It's got a single line. It's got a multi-line symbol. It's got a 3D part associated with it. It's got a 2D footprint associated with it. So for things like connectors, this is going to be your projected views. All of these are associated. And down here in this lower section, you can see the circuits. And this is really the key. So we actually have real circuit information for all of these parts, all the way down from project management level, hey, this part is going to go to this part, it's going to go to this part, down to, oh yeah, circuit, a connect terminal A1 on this relay coil is this type of circuit, and we're putting this wire to wherever it goes. So all of this gets fed into the database. And how do we get information in there? Well, we usually, I don't want to call myself lazy, I'm going to call myself pragmatic. I'm going to use import tools. I'm going to use wizards. I'm going to use import tools. I'm going to use data sheets into Excel. I'm going to do anything I can to not have to enter this information manually. And because we're built on a very powerful SQL database, we can do that. And so the SOLIDWORKS Electrical front end has wizards for just about everything. So that's it. We made it through the PowerPoint presentation. Everyone give themselves a pat on the back. Into SOLIDWORKS Electrical. So I'm going to, actually let me clear this out here so that we can do this one thing at a time. So I've got this program called SOLIDWORKS Electrical. You can see this is not SOLIDWORKS. I've got a project over here on the left, Automotive Harnessing. Inside the project is this document book. I've got some documents that I did here, and I've got a couple of folders, reports and data sheets. So this is pretty standard stuff, right? Where everyone's seen a cover page before. I included a picture of the harness that I've kind of put together representative sections of. Again, this is what my company used to produce. So this is a four-figure harness. It's a reasonably expensive harness, custom designed and custom made. So we need to talk about document types. I'm going to cover in this first section kind of how these projects get set up, what the kind of the texture of this information, what you need to know, what you can get out of it, what you should expect to take a lot of time, what you should expect to take no time. First document type would be our single line. So this is a single line. We call it a single line drawing because we're showing icons, we're showing symbols that have pictures of these devices, and we're showing single line connections between them, no matter whether that's a single wire, whether it's 100 wires, whether it's a harness, we're just showing single line connections. So this is a power supply line drawing for this representative car. This happens to be my car. So we have some components, and I'm guessing not everyone here is fully into motorsports wiring, but you can still kind of figure out what's going on. We have it's a big thing called a smart wire. Okay, what's a smart wire? Well, it connects to the battery and it connects to a couple of these connectors. It's a power distribution module. From there, we have power that goes out to some headlights. We got power that goes out to some switches. We got power that goes out to a connector to what's called an AEM Infinity. This is a very powerful engine control computer. Great. Power to a fuel pump. Everybody needs a fuel pump. And we have a battery. So what's on this page shouldn't be, mind-blowing to anybody, but what's interesting is kind of how easy this is to put together. This is a, your management level view, your customer-facing view, your 10,000-foot view, whatever you want to call it. But what's important is that these are not just pictures and lines on a page. These are symbols that represent components. So I'm going to hop over here on the left. We can see that I've got a document tree, which is where I was pulling these documents from. I also have a component tree, and a component tree can be thought of kind of like your SOLIDWORKS feature tree, or within an assembly, you've got sub-assemblies and parts. Within my component tree, I have these three locations. The main location here is the cabin. I also have a location for the engine bay and a location for rear. Inside these locations, I have components. So looks like there's quite a few, right? A lot of these show a little connector icon. Some of them show some other stuff. So, for example, if we're talking about these connectors, if I expand these out, I can see documents within these. So we talked about this SQL database, everything being based on part numbers. Well, if I come into this component and I look at its properties, I can see that this component, which I've got labeled as Infinity C1, AEM 73-pin connector, it's actually a Molex part number. MX123 family. It's a real cool family of new connectors for this stuff. This part number has a bunch of data attached to it. So we've got some metadata. We've got the important part is it's got a part number, it's got a manufacturer, and it's got 73 circuits. So I didn't put these circuits in by hand. I didn't sit here typing add 73 times. All of this stuff is easy to import and set up. So the time to get started with this is very low. I mean, into this whole project, I probably have, I don't know, 6 hours, and 3 hours of that was just making it look pretty for the webinar. So we've got this this component, and it's showing me live circuit data. So it's showing me in green over here what's being used in the project, in blue what's available and not being used. So I haven't fully detailed every pin on this connector. So the important thing to note, we have a component. It's called Infinity C1, connector 1. That component has a part number. We're linking to that part number with symbols on the page. So the reason why this is important is because I'm going to hop over here. We have another line diagram for engine control. And again, this is, I have a connector C1 and C2. These are my connectors for my engine control, and I have pictures of what all these connectors look like and what they're called. So as part of these symbols, people call them icons, people call them all sorts of things. They've got, they're symbols with pictures. As part of my single line symbol, everything has a mark. I tend to use marks that make sense for me. So these are my 8, I've got 6 injectors here, a couple more over here. Got my coil packs for my individual coil and plug, and I've got some sensors. So great. But what's important is that this connector C1 here represents, this symbol here represents connector C1, just like this guy does here on this side, on this page. So very, very cool that we're using this database to link components to each other. So we show some single line. This is nice, but I'm sure everyone is saying, well, this is great, but that's not how we do our drawings, or that's not what I need to see. Everybody pretty much needs to go to multi-line. So I'm going to come back to this, but we'll hop into the multi-line power supply drawing. So I hope I'm not going too fast here. I know I'm trying to slide through all this information and leave a little bit of time for questions. So we have our power supply single line drawing. Sorry to page back and forth here. So we had our power supply single line drawing here. This is the multi-line drawing. So some of these things are the same components. It's just we're representing them differently. Smart wire A is a 23-pin amp super seal connector. How do I know that? Because it's got a name here with the description on it, right? I didn't put this in. All I had to do to put this symbol of this connector on this screen was go to my insert connector tool up here and select a connector. And these are all of the connectors that I've added to my project. So, okay, great. So say I wanted to insert smart wire A. It's telling me, well, smart guy, this component's already inserted here. But because it's reading out of the library to see which connectors are available and which pins are available, it's very intelligent with placing either the same thing on a page representing a different way, or placing new information on a new page but still linking it back to that same component. So here we've got our actual, this is electrically telling you what's going on with our 3 switches. It's a Honeywell 1NT1 aerospace switch. We've got an ignition switch, fuel pump switch, and a start switch. But you can actually see some wire numbers here. And you can see that, one side looks like comes into the smart wire, the other side goes to a ground terminal. Electrically, you can tell what's going on. Same deal with the headlights, right? We got a headlight wire that comes out, wire 1 goes to my headlight, and then the other side goes to ground. But one of the things that's interesting about multi-line is we're not representing wires. We're not representing these things as just symbols on a page and lines on a screen. These lines, these red lines and black lines, actually represent wires, and they have wire styles. So this is part of what slows people down when they first start this software is they have to add some wire styles to the software. For this project, I was using mil-spec wire, so we have some slant 43, some slant 32, and I've got some different sizes and some different colors in here. This is not stuff that I've added in one at a time either. This is stuff that I've pulled out. I basically, do an export to Excel. I bring all my stuff in from these data sheets into that Excel. I re-import it back. So we have, basically fully documented information on each of these wire styles so that I know when I use it what type of wire to use. So for example, this is slant 43-16-2, 16 gauge, 2.1 millimeter diameter, bend radius of about 3 times the diameter, input voltage, 200 degrees Celsius, dual wall ETFE. I mean, tons and tons of data that you can throw in here. But all you see on the page is just a red line. So there's a lot happening behind the scenes, a lot of intelligence that gets added, and that's the big selling point versus a tool like Visio or a tool like AutoCAD, what people typically use to do this sort of thing. So we talked about connectors, we talked about wire styles. We can see if we go to this ignition switch symbol here and I say go to, you can see that I have, it's linked to wherever else this is in the document. So this is going to take me back to my ignition switch here on the previous page, same deal. So I can kick this back over here and I can say, hey, okay, I see that these are the same switch. Wire numbers, I can cover a little bit more. We can basically do anything we want with wire numbers. So if I come in here and I want to change the naming for this wire style, or say I want to change it, actually let's change it for all of these. Let's change it for all my slant 32s. I can come in here to my wire formula. I have another wire formula that I used recently, which was wire color and then an added section and size. So I just say, hey, you know what? Change how these are numbered. And it says, okay, I'll change how those are numbered. Well, nothing changed on the page yet. So I don't manually number anything using this software. And this is coming from somebody that does harnesses between 100 and 1,000 wires to a harness. Not having to manually number, to be able to number these things just based off of a formula that I create is amazing. So I come in here and I say, hey, you know what? Go ahead and renumber these. It takes about 2 seconds. And all of my numbers for these wire styles have been renumbered. So here you can see that this used to be wire 7. Now it's 7-red/22 gauge. So, who knows if that's actually how you'd want to number your stuff, but pretty cool that you can just tell it how you'd like things to be done, and then it does it. So that's where having this back-end intelligence is really powerful. So we got some power supply, great. Let's kick over to the engine control side. Wow, that numbering system got really busy over here. So maybe I don't want to do that. So I'll kick back here. I can do this. There's a couple of shortcuts for this as well, but I figure I'll basically do the exact same thing I just did. I'm going to change the wire numbering formula for these wires back to just the wire number. And then instead of cleaning, can you imagine cleaning this document up if this was in AutoCAD? I have to click every single one of these. Not into that. I'm going to say, hey, renumber based on the new formula, and 2 seconds later, we're back. So I've just got individual wire numbers. They're still unique, but this is going to track all the way through my project. So all of my single line stuff gets updated, all of my multi-line stuff gets updated, all of my 3D stuff when we go to 3D gets updated. So the thing I want to note here is that I've got a connector C1. This is that same connector we've been talking about, right? That Molex connector. Here we're only showing 6 pins, and connector C2 was a 56 pin, right? But we're only showing 2 of those pins. And then if we hop down here to the other side, this is connector C1, and here we're showing, looks like 8 pins. They're not continuous. I went through and told it which pins I want. I didn't have to create a symbol specifically for this page that had these specific wire numbers on it. I don't manually number anything. I just say, hey, I'd like that pin and that pin and that pin. And I mean, how do you know which pins are which when you're in the document, right? You gotta be jumping in and out of data sheets. Well, over here on the left, I created a folder within this project that has my data sheets. So I can open this. This is the manufacturer's PDF for this engine control unit for this application, and actually help develop this. And we have all of the information, so I can be just inside the project, 2 seconds into a PDF, checking pins. Okay, got the pins I want. Let's put that connector down. Let's connect our sensors. So again, everything's numbered automatically. We can pick and choose which pins we want out of which connectors, so I don't have to redraw connector symbols. I don't need all 73 pins of this connector symbol on one page. If you do a lot with wiring and connectors, the software saves so much time. So anyway, the other thing I wanted to point out while we're still here is what's called nodal indicators, N-O-D-A-L. Some people are familiar with this from PCB, some people aren't. What this is these little slants that basically show you graphically where the wire is going. So I have these two ground wires from each of these coil packs that all go up to a single ground terminal, and you can actually tell just from this page which way these are going, and by the wire numbers you can tell that there are indeed 8 wire numbers that come up to this ring terminal. Therefore I know all of these are going the correct way. You know, I have a single run from one of these, or from each of these coil pack connectors up to our ring terminals. So nodal indicators were new for 2016. They can be really handy. So here I've got bust sensor grounds and bust 5 volt, and it's really important that I don't run a wire from, you know, pin 42 over here on the right of connector C1 over to pin 40, and then another one from pin 40 up to pin or to wire 44. It's very important that these are disparate, you know, discrete runs all the way back to this pin down here. So I can actually use my wiring connection order here to tell which direction it's going. So we can see that if I change the path, that actually is a different connection order than if I change it here. So, and you know, again, if you change this, you renumber, and here we go. So I've actually changed it so that these both now meet here at my map sensor, which is not what was intended. So I can edit the connection path. I can do this graphically, change this guy back, and all I have to do is, again, not numbering anything manually, not putting any text on a page. Now we can see that wire 41 and wire 40 both run down to this connector down here. So nodal indicators, new for 2016. Very cool. So this is a very simple thing going on. What I wanted to show really quickly before we talk about the last piece, which was reports, is the connection between these wires and what you see on the single line. So if we kick over back to our engine control single line document here, we know that these coil packs, you know, coil packs 1 through 8 here are the same as coil packs 1 through 8 here. We know that because they're all named, and all these names are consistent. I'm not manually typing these names. There's no chance that I'm going to fat finger one of these and they're going to be the, you know, the wrong names, or 2 things are going to have the same name. It's all tracked by the database. So we know they're the same names. So the software knows that between this component, connector C1, and this component, coil pack 1, that I've got a wire. And so it doesn't know, it doesn't know about any cabling or anything like that, but this single line is intelligent. And so it's telling me that from pin C, from coil pack 1, and I can click it and it turns yellow over here, I'm going to connector C1 pin 11. So this is intelligent from one document to the other. Now the other way to do this, if we want to do everything with discrete cables, something like my crank angle sensor, right? This is a Hall effect sensor, not super high speed in terms of, you know, industrial or gas turbine engines or anything like that, but it is automotive is a pretty nasty environment. So I'm going to use a 275000 22 gauge shielded cable for this. So if I'm just showing one line here on the screen, one connection between these two components, but I can actually fully document that connection. So this is cable, I'm calling this cable CKP, 3 conductor shielded PTFE 200 degrees C, and I've got my individual conductor colors here, so I know how to wire the damn thing, right? So, you know, pin A comes over here to C121, and, you know, so, and such. So this also can be done coming from the multi-line, like our cam sensor here. It's just we didn't define a cable. We're using just individual wires. But still, I did not enter this information in to this tool. I entered it in from over here, right? Here's my CMP, my cam angle sensor. Again, Hall effect sensor, and it comes into Infinity connector C1. I'm documenting it here in multi-line, and it's also showing over here in single line. And if I wanted to then create a cable for these and, you know, not make them individual wires but use a cable, I can easily do that. It would, and associate those cable cores. So that's kind of the, you know, in a very quick showing, we have association between single line and multi-line, all based on our component tree, and our circuits are based on our component manufacturer's parts. Those manufacturer parts have circuit information. There you go. So the last part of this for the 2D section before we go to some questions here, we talked about some document types. We didn't really go too far into the manufacturer parts, but manufacturer parts give us our circuits. What do we do once we actually finish these drawings? We want to actually make this stuff. So we've numbered our wires. We appreciate that happens automatically. We come up here to the Reports tab. So I've got, by default, a few of my favorite reports in here. So one of them, very simple, it's a drawings list. So we've got a list of all my drawings, and it includes my data sheets. I can put some descriptions on here. So I have, a lot of this stuff for this application is Delphi GT series connectors. So I've got the GT series PDF in here, which is, pretty handy, right? We've got all of our part numbers. We've got some, some derating curves. Nice stuff to have right at your fingertips. So I'm in here in my reports. It's telling me about what's in here in drawing list. Great. What I'm most concerned with is these wire tags. So we all want to tag our wires, right? We're using harnesses, so wire numbering is kind of all we got. Here I'm using individual wire marks. So these are our wire marks from the automatic wire numbering that took place. And you can see that I've got a quantity of 2 because it's going to put 1 by default on either end. Great. Bill of materials by manufacturer, very helpful. A list of wires by line style. So this is going to say, hey, you were talking about some, 275 or some 22759 slant 32-16-0. Here's how much you're going to need. Very helpful report. And then the last one is cables grouped by reference. So I only have 1 cable in here. So great, I can get an Excel, Excel file from here. This is all database format. But what I want to do is create some drawings. I'm going to have it generate these. And I'm going to say, go ahead and put these inside my reports folder. I'd already done that, but then I deleted them right as we got rolling here so I could show you how quickly these generate. So put those in the reports file. Go ahead and leave the drawings list in the main folder here. Click OK. It takes about 10 seconds. So it's done. Tells me everything was generated. Now we can see that inside my reports folder, I've got my drawings list. That's nice. I appreciate that. Everything gets output on my title block, of course. I'm not doing any of this manually, right? Hop in here to my wire tags. This is what I would feed into my label printer. So, our wire numbers weren't particularly exciting after I kicked everything back to just be a number. But, so here's everything, and here's how many I'll need. Bill of materials by manufacturer. This is probably my favorite because I order everything. Basically, I have a distributor for a certain manufacturer. So AEM, I'm direct. AMP, I'm going to have a distributor for. Braille, a distributor for. Delphi, a distributor for. So here's the part numbers. And so for all these things like injectors and coil packs where I've got 8 of them, it groups them all here, tells me what they are, and then says quantity 8. Pretty nice. So here over on the other side, we've got some ring terminals. We've got my switches, some OLX connectors. Same deal. Now, list of wires. This one takes a little more explanation. So this is by wire style, and it says origin, destination, what the wire number was, its section, and then once we route in 3D, which you'll have to come back Friday at noon for, you can see the actual lengths. And so a couple of these, I think, are left over from when I had everything routed. Yeah, I've got some 22 gauge wire here for those switches, and you can see we have routed lengths down to, I cut it off at the 100th of an inch. So wire number 6 is exactly 24.51 inches long. These 3, 27500 slant 32-22-9 white wires. I've got 3 of them. I need a total of 70 inches for this project. Very helpful for estimating cost beforehand. And when you know the exact wire lengths, you can really cut down on slop. So if you're building a lot of harnesses, you know that the shop floor is filled with these, somewhere between, maybe an inch and a couple feet long of this slop that was just measured extra so you wouldn't measure too short, and then they cut it off and kind of toss it in a bin. So we can actually cut down on some of that waste here. And similarly, only some of the stuff was left over from the last time I routed this. We have some more white wires here. List of cables is an easy one. We only have that one cable. It never got routed, but this is kind of the same deal. It would give us our origin destination components, and this is the part number for it, so we know what to order. So we covered at breakneck pace a little bit of intro about SOLIDWORKS Electrical, why it's useful for things like wires and harnessing, what it's not used for, right? SOLIDWORKS Electrical is not a PCB tool. We actually have a new SOLIDWORKS PCB, it's its name, very creative, for PCB. We talked about kind of how it works. So we're relating everything to these components. We're placing symbols on a page, right? So we have our single line symbols. We have our multi-line symbols. They're all related to each other through that component tree. We do automatic everything. I mean, anything that can be automated is automated. So things like wire numbering, things like enforcing that you're using the same wire styles, using the same configurations. Everything's configuration based. I'm not drawing things manually, which is awesome. So we also talked about reports, kind of, not so much how to edit them, but these were reports that were already included in SOLIDWORKS Electrical, so I just grabbed them. And because of having these reports and these data sheets here in the same project, when I go to export this, it's incredibly easy to either, I can do a print if if you're one of these people that still uses paper. I can go and export to PDF, right? So just right here, export to DWG, export to PDF, and my project will have everything that I need. One click, yes, go ahead and give me a PDF, takes 10 seconds, pulls everything in, and I'll show you what it spits out here. I have to drag it onto this screen here. Here is my project PDF, automatic. Very cool. Now, we talked about linking back and forth. I told you how I can link from this switch to the next representation of this switch in the software. Well, those links persist through into PDF. So this is the most intelligent PDF output I have ever seen. So going through, we got some switches here. Maybe that's interesting, maybe that's not. But what's really nice is if I'm looking at everywhere where, say, this connector C1 is used, they're all automatically linked one after another, and I can just click through my document in a loop. I can also edit these and go to the data sheet if I wanted to. So when I'm doing preliminary stuff, showing people, hey, I think this is what your project's going to look like. I think this is what what parts you're going to use. I can just say, hyperlink straight to the data sheet from within here. Anywhere where we want to say, let's add a hyperlink. Boom, here we go. Add a hyperlink. So really powerful schematic tool. This is where most of the value is for our customers. I definitely didn't have enough time to go to 3D, so that's why we broke this into a second section. So if you would like to return Friday at noon, I think everyone that's on here would have gotten an invite for that one as well. We're going to basically pick up from where we left off here, show 3D routed geometry, and a little bit of some of these manufacturing outputs on the back end. So how do we flatten a route? How we can feed those lengths back into reports, where we were looking at these list of wires that didn't have lengths. We're going to route all of our wires automatically, feed these lengths back in so that we have even better reports, and of course some of this manufacturing data. So it took about 10 minutes longer than I'd hoped, but not too bad. I'm going to look through my questions menu here. Does anybody have any questions that they would like to cover? Let me put this guy up here. This was going to be my last slide. GoEngineer, as always, provides design and manufacturing tools with the expertise, enabling our customers to reduce cost, risk, and time required to go live with new technologies and new product. My email is down there on the left. That's really the reason for this slide. jjordan@GoEngineer. You are more than welcome to email me with any questions or anything you saw here that you liked, things that you kind of wondering whether or not it works for you. Or you can email back marketing, and they will forward those over to me as well. Thanks very much for checking this out. Feel free to email me with any questions or comments, and hope to see you guys all here on Friday.